So welcome to Advanced Algebra 1. We're going to start off with some real basics, talking about the different types of numbers. And I do something kind of strange. I just make up dumb stories to get the point across. But would you believe, long time ago, like, they had to just, like, invent mathematics. And you'll learn more about that when you take advanced geometry. But everything that we have been taught has literally been made up. Quick example, why is the color blue called blue? They made it up, you know? It's like, why didn't they call it hippopotamus? You know, it's like they made up the name blue, and everyone said, cool, we're going to call this thing blue, right? It's the same thing with our numbers, you know? So, like, here's my dumb story. Let's pretend we're going back hundreds of years ago. There's this apple tree, and all these apples, like, fell on the ground. And there's two dudes. One dude doesn't even have a name. He's just a dude. And the other guy's name is Dave. And the dude looks over to Dave and is like, hey, look at all these apples on the ground. I wonder how many there are. And he's like, I don't know, man. We don't have numbers. So it's like, maybe we should invent those numbers to, like, create it. So they started counting the apples, and they made up numbers. And you already know these numbers. Like, if I asked you to start counting right now, how would you go? Go for it. 1, 2, 3, 4, 5, right? We don't start with 0, you know what I mean? And we don't go 1, 1.1, 1.2. We don't use decimals or anything. Like, didn't they go 1, 2, 3, 4, 5, right? Why did they call it that? I don't know. They made it up. You know, they actually didn't call it that because they use a different language in Greece, you know, but it's still, it's like when it translates to English, it's 1, 2, 3, 4, 5, and those are what's known as the natural numbers. If I asked you to start counting, wouldn't you naturally go 1, 2, 3, 4, 5, and doesn't that keep going forever and ever and ever to a thing called infinity, right? So our natural numbers are our counting numbers. If I asked you to graph them on a number line, we would put dots on the number line. So, like, 1 is a counting number, 2 is a counting number, 3, and etc. And that pattern just continues. We've used the number line before, correct? You know, so, okay, good. But what mathematicians do is they hate to write. They don't want to write out the natural numbers all the time. They create symbols for these things. And that's what makes math difficult for a lot of people, is they don't know how to read it. They're like, what does this say? You know, these symbols. So natural numbers is a pretty easy symbol. Oh, my bad. Let's do the set first. As a set, let's use these, let's use these fancy schmancy little set brackets. You know, you can kind of see them on your keyboard. They are hard to make. If you have a hard time making a set bracket, it's just a squiggly little parenthesis. I'll do that one more time, you know, a set bracket. So if I can get my pen working, it's been a whole summer for me. But if you have a hard time with it, just make like a squiggly little parenthesis, but don't use a parenthesis because that means something else, right? So cool. But isn't the set of our natural numbers go 1, 2, 3, and then we'll put the little dot, dot, dot to mean, hey, that pattern continues, and then we close that set off with a bracket. So your homework today is going to be online, like I told you, and it's going to say, hey, let's type this set in. Sometimes you have to type those little squiggly brackets. They're on your keyboard. I'll show you where they're at. And sometimes you don't. It's just, that's going to be the frustrating part about it. But see how I put a comma in between them? Like, you'll have to type that, right? You won't have to type a dot, dot, dot. But back to my cool little symbol thing. The cool symbol for natural looks just like an N, but we call it the double bar N. How do you make it? First, make a capital N, just like that. But the reason why it's called a double bar N is because we throw this extra little guy in right there, like a double bar N. And that's what its name is, the double bar N, right? You know, it's the double bar N. So that's for the natural numbers, 1, 2, 3, etc. So cool. Dave and the other guy could count up the apples. It's like, cool, there's 1, 2, 3, 4. And then what happened, I'm just making up a dumb story here, is they ate them all. It's like, oh, sweet, they're all gone. How many apples are there now? They're like, I don't know. We don't have any. So they had to invent a new number. You know what that number is when there's none of them. Which number did they have to invent? 0, right? So 0 is what makes us go into the whole numbers. The whole numbers is all your natural numbers and 0. All your natural numbers and 0 are the whole numbers. We graph them on the set, on the number line like this. 0's there, and then all those other naturals will still be there. So 0 was added to it. When you're writing it as a set, you put your weird little bracket, but this time it starts with 0, and then all those other naturals will still be there. 1, 2, 3, and that pattern continues with the dot, dot, dot. And if you were not an advanced student, most teachers would show you to use a W for the symbol, which doesn't exist. I can't show you what the symbol for whole numbers is yet until we learn what the symbol for integers is, and I'll come back to it. Since we're advanced, we're going to do stuff advanced. There is no W in math. It's made up to make people understand whole numbers. So let's talk about the integers. Now my little apple example kind of doesn't make a lot of sense, but the integers were, okay, we've invented the naturals, we've invented 0, and then somebody said, well, what if we did like the opposites of those, like invented negatives, you know, like -1, -2, -3. That's where integers come into play. So sorry about that. The integers is all the naturals and their opposites plus 0. The naturals and their opposites plus 0. And don't worry about those little Venn diagrams I have drawn off to the side. I'm not too concerned about those. The naturals and their opposites plus 0. So I'll be the guinea pig since it's our first real day. I'm going to list a natural number. Is 7 a natural number? If you went to count, would you naturally come across 7? Yeah, 7 is a natural number. What's the opposite of that? -7. See how that takes care of the negatives, right? The opposites means, okay, I'm going to make it negative, right? So if I just listed every natural number, like 1, 7, 15, 55, those are all natural numbers, and they're opposites. You see how 0 never gets in that list, right? So you have to go the naturals, their opposites, and 0, right? So that would be all these guys. All the negatives, all the naturals, and 0. And it is the most mistaken because people think those are called the whole numbers. It's like, oh, it's a whole number because it's not a decimal, right? And it's like, no, negative numbers aren't whole numbers. Whole numbers are the naturals and 0, right? So it's weird, right? You know, but in the real world, most people would still kind of call those whole numbers. They're not. They're integers. Integers. And as a set, it's kind of like really, really weird because if you look at my blue dots, like how far to the left could I go? Like would -4, would -5, would -6, could I keep going forever and ever and ever? So like wouldn't I need to actually start with the dot, dot, dot because it's like, hey, it's going to go on, we're going to say that to the left forever on the number line, right, to a place called -infinity. So then I'll go, okay, and then it's like maybe like -2, -1, and then 0. And then 1, and then 2, and doesn't that keep going on forever to the right? So it's like a dot, dot, dot. So like all these things are related to each other. The number line is the same thing as the set. You know, you're just like graphing it one way, you're writing it another way, and then the symbol is weird. It has nothing to do with the word integer. It is probably the Greek translation that I always forget to look up, but it's the the double bar Z. Z is the symbol for integers. So that's a normal capital Z. We'll make it double bar. The double bar Z. And now we're allowed to go up and do the whole number symbol because we know what the double bar Z is. Double bar Z means integers. And I'm going to give a symbol to you. I know it's the first day and we're a little rusty on our math brain, but you've seen it before. Have you ever seen that symbol before? That's greater than or equal to, right? 0. And this is where it becomes challenging to a lot of people because I'll say, translate that to English right there. That says the integers greater than or equal to 0, right? And would you agree that all of these numbers are integers? Right? Isn't 1 an integer, and 2 is an integer, and 3 is an integer? 0 is actually an integer. But you know what this says? No negatives. If you're greater than or equal to 0, you don't get any negatives in there, right? So the integers greater than or equal to 0 is called the whole numbers. It's like, hey, no negatives, bro. And that's kind of weird for a lot of people. But we'll get used to it. The more you practice something, the better you get at it. It's like riding a bike without training wheels. The very first time you rode a bike without training wheels, you probably fell down, you know, and it's like, but you keep trying and you figure it out. And now, let's go back to the apples, the rational numbers. Old Dave and the other guy had the apples. They could count them up, do all that stuff. And then one day, Dave took a bite out of the apple and set it down. And they're like, whoa, that's like not an entire apple anymore. Like, we can't call that one apple. It's like not all there. Maybe it's like half an apple. You know what I mean? They had to invent the fractions. They had to invent the decimals. It could be 0.5 of an apple or anything. That's what the rational numbers are. It has a really, really complicated definition. So let's see what we got here for a definition. Maybe. Numbers that can be expressed in the form a over b. I'm going to just read it to you in pieces. Numbers that can be expressed in the form a over b. Numbers that can be expressed in the form a over b, where a and b are integers and b is, take a guess what that symbol means. It's an equal sign crossed out. Guess what that means? Not equal to, right? B is not equal to 0. So we'll write it down and then we'll kind of discuss it. Numbers that can be expressed in the form a over b, where a and b are integers and b is not equal to 0. So like I said, that's fancy schmancy math talk right there. Now let's break it down into something. How do you feel? I know it's our first day calling that a fraction. Is that pretty cool that that's a fraction? Guess what? You've got a numerator, you've got a denominator, correct, right? The numerator and denominator have to be integers. Okay, what does that mean? So the integers are like 1, 2, 3, -1, -2, -3. You see that you have to use integers for the numerator, integers for the denominator. But what's this all about? The b, who is that? Numerator, denominator? Denominator. They said it can't equal how much? 0. That's the first commandment of mathematics. Thou shalt not divide by 0, right? It's just mathematically impossible. You can't split something up 0 ways, right? So that is a fraction. What I'd like to do off to the side is put English translations to this. So if you got room off to the side, I'm going to write it over here, but you might write it to the side. Rational numbers are fractions. They're fractions, which America is probably one of the few countries in the world that uses fractions. Most of the world uses the metric system, right? So they use decimals. Are you cool with that? So, but there's different types of decimals. There's a terminating decimal. We'll write it down, then we'll talk about it. So a terminating decimal is another thing. Terminating decimal. How do you feel about the word terminating mean? It stops. Like if I terminate something, you know, long time ago there was movies of the Terminators, like it means you like end something, it terminated, right? It terminated, it stops. Like I'll punch one in my calculator right here, just to kind of get that going for you. If I punch this in, 1 divided by 2, I will get a decimal back, right? Does this decimal stop or fill up my entire screen? It terminated, right? Isn't 0.5 1/2, right? You know, that's why it's a terminating decimal. 3/4. What's 3/4 as a decimal? It terminates, right? You know, it terminates. But then, 1/3. That does not terminate. Would you believe that that goes on forever and ever and ever and ever? But you probably used to put a little bar above that, right? You know, a little bar. That's because that's called a repeating decimal. Any repeating decimal. Any repeating decimal is also a rational number. And how will you know it repeats? You can see a pattern to it, or they put the little bar over it, just like this, 0.12 with a bar. It either goes 0.121212121212 forever and ever and ever and ever and ever. But check this guy out. What's that symbol mean? Just out of curiosity. First day, I know. Square root 2. Is that a decimal? You better believe it. Did it fill up my whole screen? Yep. Is there a pattern to it? Well, 0.414, I kind of see a pattern, but then it goes 2, 1, 3, 6, 2, and that's just going to get weirder and weirder and weirder and weirder. Let's bring you back to the super weird guy. You remember that dude? What's that guy called? pi, you already know that that goes on forever and ever. It's 3.14159, blah, 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 blah. There is no pattern to it whatsoever. Those are not rational numbers. I can't write it as a fraction, right? Because people are like, well, why don't you call it pi over 1? Well, isn't pi over 1 like a fraction? Cool. Isn't the rule say you got to use integers to make up a rational number? Pi is not an integer. It's not natural. You don't sit there and count, hey, 1, 2, 3, pi, 4, 5. You don't do that, right? It's not natural in that case. So that is not a rational number. So some examples you can kind of put in there. I had like my point 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. You know, like 3/4 was cool. You know, 0.5 was cool. Here's the big question. How about 7? Is 7 a rational number? Let's put it into real talk. Can you write 7 as a fraction using integers? 7 over 1. 7 is a rational number. 11. Is 11 a rational number? Yep. -5. -5 is a rational number. So the rational numbers are like everything that we've done before. If I was going to start graphing them on the number line, it's like, cool, there's a rational number like 0.3, 0.4, 0.5, 0.6, and then you can have 0.32, 0.33, 0.34. Like there's a bunch of them, you know what I mean? There are all those weird decimals in there, but they have to be terminating decimals or repeating decimals for them to be a rational number. The symbol for it is a funky one. Makes sense in a little bit. It's the double bar Q. So make a big capital Q. And people are like, how do you make the double bar part? We don't do it on that little staffy thing. We do it right here. Boom. The double bar Q. And I'm just guessing that that's for quotient. Have you ever heard the word quotient? Like sum, difference, quotient, product kind of stuff. Quotient is divide, you know, so it's like a fraction thing in that case. So, whew, look at all those types of numbers. And then, of course, there's like, this is the set of all those dudes that we've done so far. They all fit inside of there. And I want to, do we not have real or irrational? Do we not have irrational? Oh, it's down low? Okay, thanks. Before we get to irrational and real numbers, let's talk about like some perfect squares. I'm happy that many of you saw the square root symbol. Again, it's totally cool if you're a little rusty. It's the first day of school, you know, so we're a little rusty, but squaring a number means you're going to take it times itself, right? So this right here says 1 squared, and eventually it's totally cool if we got to put stuff in a calculator. We're going to have our first 15 perfect squares memorized to where you don't need a calculator for that. I'll bet you could do 10 of them without even a problem right now, you know, if it wasn't the first day of school, right? What's 1 squared? In other words, 1 times 1. It is 1. It is probably the most brain-farted one because sometimes we accidentally put 2, you know. It's like, my bad, that's 1 plus 1, you know. It's like 1 times 1 is 1. What's 2 times 2? 4. Why don't you and a neighbor see how many you can get without using a calculator? And if you're not sure, guess, right? And if you're wrong, who cares, right? Who cares? Give it a show. All right, 3 squared. Let's roll through them. 3 squared, 9. 4 squared, 5 squared, 6, 7 squared. That one is missed a lot. You know, a lot of people accidentally put 42. I get that, you know, but there's 49. 8 squared. Yeah. And then 9 squared. And 10 squared is kind of a freebie. It's 100. Those, I hope that we were pretty comfortable with. If you didn't know the rest, that's very normal, right? You know, but 11 squared, anybody? Yeah, 121, right? Very good, right? 12 squared. Nice. 13 squared. Very good, very good. And then I got a little secret. If you know 13 squared, you know 14 squared because you just switched the 6 and the 9 around, right? So what's 14 squared going to be? 196. And then the last one, again, if you didn't know that, those last ones, it's no big deal, right? But you'll see when we start doing some quizzes and stuff, I'll always say, write your first 15 perfect squares on the back and do what you can without a calculator because you will be shocked of how much those are going to come into play in your math life for sure. And then in real life, it kind of helps a little bit here and there too. And if you can do them fast, I'll tell you right now, your ACT score, very high. ACT Math is 60 questions in 60 minutes. We're smart. What's the average time length you get to do a question? 1 minute. Some of the questions are really, really hard, too. So you need more than a minute, right? So like the faster you can get other stuff done, the more time you have to get things. And if you've got to waste time punching stuff in a calculator, it just costs you time on that test, right? So I'm trying to save you time. That trust factor. Trust me. I'm making you do stuff for a purpose. Cool? So, all right. And then you already saw the square root. A lot of people, if I ask you what's the square root of 25, you know, that means find two numbers exactly the same that multiply to be 25. They go 5, right? And then they also say negative 5, right? Because isn't negative 5 times negative 5 a positive 25? And you're right if I ask you to solve this equation. If I said, hey, if x squared equaled 25, what could x be? X could be 5 or x could be 25. Or, excuse me, I'm sorry. X could be 5 or x could be negative 5 in that case because you're solving an equation. But when you're just simplifying a radical, when you're just asking, hey, what's the square root of 25? They only want the positive dude. They just want it to be 5. And we'll get way deeper into that when we start solving equations, right? You know, but it's just like when they ask you what's the square root of 25, they just want 5. What's the square root of 4? What are the two numbers that are the same that multiply together to be 4? 2 and 2, right? So 2. And then you see here how they have a negative on the outside of that square root, right? So it's like, hey, please find the square root of 36 first. What is the square root of 36? 6. And then the negative just comes along for the ride, right? It comes along for the ride. And then the last one here, square root of 196 is, man, didn't all those come out so perfect? Because everything up to number 5 was taking the square root of a perfect square because they came out to be integer answers, right? But what's the square root of 7? I could punch it in, right, and get a decimal back. Is it coming out nice? Like, is it, when I say nice, I should clarify that. Am I going to get an integer back on this, the square root of 7? Why not? 7's not a, tell your neighbor if you want, 7's not a perfect square is the answer. 7's not a perfect square. And I heard someone say it's the prime number. I like that, right? It is a prime number. How about square root of 10? You know, 10's not a prime number because isn't it 1 and 10, 2 and 5, right? Like, so square root of 10, is that going to come out nice, integer, or nasty? You know why? Because 10's not a perfect square. Square root of 11. Square root of 49. Is the square root of 49 going to come out nice? Because 49 is a perfect square. When you square root a perfect square, those are called inverse operations. They undo each other in that case. So that leads us into our very next answer, the guys that come out nasty. The square root of 7 is just the square root of 7, dude. You know, that's it. Keeping it clean. So the nasty boys are called irrational answers, right? They're irrational. Ir means it's not. So it's like it's not rational. Are you with me on that? It's totally not rational. So it's another complicated little definition. But it's numbers that cannot be written as a terminating decimal or a rational number. Numbers that cannot be written as a terminating decimal or a rational number. Numbers that cannot be written as a terminating decimal or a rational number. I'll give you a couple examples, and then we'll see how we can go with it. Here's the first one that everyone runs to. What's that number again? Pi. Isn't that, I just call them nasty. Isn't that nasty little decimal? You punch that in, it's not repeating, it's not terminating, there's no pattern to it. Here's another one. Square root of 2. The square root of 2 is irrational. And I'll give you one more. The square root of 5. Tell me why they're irrational about these numbers I'm highlighting in green. What are those numbers in green? Not. They are not perfect squares. Come up with one more, you and a neighbor. What's another irrational number? You're going to have to do a square rooty guy until we get square root of something, right? Cool. Francie, what's yours? 3? Like that? Just 3? Oh, there we go. That's the other thing. I'll bet you wrote it down right, Francie, but to say it out loud is a little different, right? So it's just like, she didn't mean 3, so that's the harder part for a student is to say what you really mean, right? So good, good, good. I love it. I love it. Give me another one. Grayson, what's another one? There we go. Square root of 6. Cool. I'm going to try one, right? Ready? Square root of 16. Rational or irrational? Can that simplify? What does the square root of 16 simplify to? 4. So watch out for the tricks on homework, right? They're going to ask, hey, is this rational or irrational? Is this rational or irrational? Just because it has a square root around it doesn't mean it's irrational. You have to see, can I clean that up? Are you with me? Can I clean it up? So before I show you the symbol, let's talk about the real numbers. It's all the rationals and all the irrationals put together. The set of rationals and irrationals. The set of rationals and irrationals are what's called real numbers. Every number you've ever seen in your life has been real. And then you get to advanced algebra 2 and you start dealing with some imaginary numbers, but that's for another year, right? But everything that you've ever seen has been real. I don't care if it's 1.32567, that's a real number. It's either rational or irrational. The symbol, do you know it? We've done all this double bar. Have you ever seen the symbol for reals? Take a wild guess what it's called. Not just R, but the double bar R, right? So make a capital R. Sometimes I do the double bars first in it, you know, but it's just like a capital R that's double bar. The double bar R. The double bar R. And we needed that so I could do the irrationals. It's kind of complicated. It's the reals, and then this is the complicated part, because I would bet you that you thought that that symbol meant divide. Notice it's kind of like a different backslash than that situation. That means take away. It's weird math talk. Reals take away that. Could you look back either above or below and say, what does that Q mean? What's that double Q mean? Tell your neighbor, what's that double bar Q mean? Yeah. If you had the reals, right, and you took away the rationals, what are you left with? Irrationals, right? It's the reals take away the rationals, right? So crazy stuff right there. So let's go practicing, right? Let's go practicing on the back side. I don't know how many of these we have to do, right? You know, we're in advance. I just want to get comfortable with it. But it's going to say, hey, name all the sets or set of numbers each real number belongs to. And you have this little Venn diagram up here at the top, right? Let's do a little cheating, right? I'm going to go put the symbols next to all these. So, real numbers isn't the symbol for that double bar R, right? So I'm going to put that up here. What is the rational number symbol again? It's cool to flip back. That's why we take notes, you know. Rational symbol is what? Q. Yep. And you don't have to say double bar as long as you write it correctly, right? Double bar Q, right? Integers is the double bar Z. Whole is the weird one, right? That's the double bar Z greater than or equal to 0. But natural is a pretty easy symbol. It's the double bar what? N. Natural. Double bar N. That's a bad looking one. Also, if you can't read what I write, please ask. I don't have that bad of handwriting, but sometimes writing on this device it slips and you can't, it's like, what's that say, you know? Irrationals is the reals, take away the rationals. So holy cow, man, first day of school, look at all this new stuff. I'll show you the secret to success, at least in my opinion, is to make up things called acronyms. You know, it's just like maybe for the colors of the rainbow, you learned Roy G. Biv. You know what I mean? And it's like for musical scales, every good boy deserves fudge. Or sometimes they change the phrase of all that stuff, you know. Like never eat soggy Wheaties, you know, for your north, east, south, and west. Mine's dumb. Like it's totally cool to laugh at it, you know, but I was like, okay, I want to come up with like a phrase to go through this. So here's what I did. You can write it down if you want to. I go, really quiet zebras won't neigh. You know, like a zebra's like a horse, You know what I'm saying? And the sound a horse makes is called a neigh. You know, really quiet zebras won't neigh. Gets me through the list with a cheat, because the won't takes care of the whole numbers. It's like cheats with a W. Really quiet zebras won't neigh. Feel free to write that down if you want, because that will answer all of these questions for you if you kind of know what R, Q, Z, and the W and the N stand for. So really quiet zebras won't neigh. You spell neigh like this, N-E-I-G-H. Really quiet zebras won't neigh. So here's how I roll. Homework kind of does it backwards. They have it like going the other way around. I don't like going the other way around. I don't care how you do it, but I'm going to go really quiet zebras won't neigh. And here's my question. Is 4/5 a real number? And you're going to say yes to that every time. Isn't every number you've ever come across a real number? So we will put the word. 4/5 is a real number, and then in parentheses I want to put the symbol. 4/5 is a real number. And then you have to make a decision. You have to decide, is it rational or irrational? You see the chart, it splits. It's like you're either this or you're this in that case. You have to decide, is 4/5 rational, a.k.a. a fraction, a decimal, or a repeating decimal? Is 4/5 rational? Yes. So that puts me on quiet. I got really quiet, so it's rational with a double bar Q. Really quiet. I'm kind of going through my little weird acronym. So it's a real number, it's a quiet number if you want to call it that, but it's called rational. And then I want to see if it's a zebra, right? Is it an integer? Is 4/5 an integer? Please look back. Don't be afraid to use notes. What's an integer again? It's the naturals, 0, and their opposites. Does 4/5 fit into that? So we are done, right? That is classifying 4/5 as every type of number. It is a real number, it is a rational number, and that's it. Cool? Done. Let's try again. 12. Is 12 a real number? You will say yes to that every time until we start getting into imaginaries, which is your junior year. So it is a real number. And I want to decide if he's quiet. Is he rational? Because if he's not, he's got to go into the irrationals. The irrationals are the weirdos. They're pi, square root of 2, square root of 5. So what do you think? Is 12 rational or irrational? It's rational. It's rational. So really quiet. And I got to see if he's a zebra, right? Is 12 an integer? Feel free to look that up. Is 12 fit naturals, their opposites, and 0? Does 12 work? Yep, so we got to spell it right. It's the most misspelled one, integer. Feel free to look it up. So he's a zebra. Sorry, that didn't work out right. There we go. Really quiet zebras won't. Won't is code for whole number. Is 12 a whole number? Feel free to look. And if you run out of room, cool, you can go down below. I'll do that here. So he's a whole number. And the symbol isn't a W. It's integers greater than or equal to 0. He's a whole number. So really quiet zebras won't neigh. I want to see if that's a natural number. Is 12 a natural number? If you started counting, would you naturally come across 12 when you did that? Yep, so he is natural. That's the way I like to do it. Some other people do the complete reverse. They're like, well, I already know 12 is a natural number. And dude, if you're a natural number, you're everything else. You know what I mean? It's just like it's all going to work, right? So some people like to go backwards. And I don't have a problem with that as long as you get this question correct. Does that make sense? So if you had it all listed backwards, doesn't hurt my feelings. But I think for all these other dudes, I like to kind of go in order, okay? Everything's going to be a real number. I decide if it's rational or not. So let's try one more of these real quick, and then I might turn you loose. What about -6? Is that a real number? Yeah, everything's a real number in our world. But it's decision time, rational or irrational. The easy way is to know that irrationals are the weirdos. Pi, square root of this, square root of that, that are not perfect squares. So what do you think? Rational or irrational? It's rational. So really quiet. Zebra time. Zebra is the integers, right? Is a -6 an integer? Yeah? Cool. Integer zebras. Is -6 a whole number? Don't let your brain trick you. Your brain might say, yeah, -6 is a whole number. Is -6 a whole number? Whole numbers are the naturals and 0, right? So even though it doesn't have a decimal with it, it's not a whole number. Those are integers. Cool? All right, let's see. Maybe we can make number 9 our last one here, right? Talk to me. Is square root of 11 real? Sure is. Is the square root of 11 rational or irrational? Yeah, he's a weird bug. He's a hard one to spell also. It's got a couple R's in it, right? So good advice for smart students like us. Sometimes the words are in the instructions that they're asking you to spell. It's like you should never spell a word wrong if it's in your instructions. Sometimes it is, sometimes it isn't. But it's right there on my worksheet, you know, so I could look and do it. What's the symbol for that guy again? R take away Q, right? R take away Q. Or even if you say R/Q, I'm fine with that, right? R take away Q. Reals take away rational. And that's it. You can't go any further. You see on this chart right here, those other dudes don't exist. Integers are not a part of that. Like when you're irrational, that's the end of the story in that case. Cool? So, all right. Let's just talk about this one. Is that real? Yep. Rational or irrational? Just out loud. Yeah, because even though it's got a square root, isn't 16 a perfect square, right? So then you got to go. So what I do is I go, nope, that's 4. Do you know what I'm saying? If I can simplify it, I'm going to simplify it so my brain isn't even looking at square root of 16 anymore. It's looking at 4. So I'll do it out loud. You don't have to write it down. I think we get it. It's a real number. It's a rational number. It's an integer. You know, it's a whole number. It's a natural number. Are you with it? It's all of it in that case. So cool. Let's go down to Scary Town. We already did the perfect squares. Is that right? Did we do that on the left? So don't worry about filling that out again. But check it out. A lot of people get scared by fractions. I totally understand that. My job is to help ease you. They also get scared by that square root symbol. Look at the square root, but look underneath there. I love the number 4, and I love the number 25. I love 36, 49, 64, 81. What's so great about 4? What's so great about 25? They are perfect squares. And aren't they asking me to square root this guy? What's the square root of 4, y'all? What's the square root of 25? So the square root of 4/25 is 2/5. Are you with me on that? There's a perfect square in the numerator. There's a perfect square in the denominator. What's the square root of 9/16? I love me some 9 and I love me some 16. What you got? 3/4. Try those other two, baby. You can tell a neighbor. Anytime, we can always work together on practice worksheets. The only thing we can't do it is on quizzes and tests, right? You know, quizzes and tests, you can't work together. Check with a neighbor. Square root of 49/81 is 7/8. And then, is 1 a perfect square? Yeah, he's the first one, right? You know, it gets forgotten about a lot. You know, people always run to 4, but square root of 1 is 1. Square root of 4 is 2. Yes. Thank you very much. Hey, I am human just like everybody else. I knew a 7/9. For some reason, I wrote 7/8. So thank you, thank you, thank you. Cool? How do you feel about that? Nice. Let me know if you have any questions. Have a good one.